Welcome to Algebra 1, Unit 6, Lesson 6-4, Standard Form, Part 2, Pearson Algebra 1, Copyright 2009. I'm Mr. Pilarski, and our objective today is I will be able to write equations in standard form. In the previous lesson, Part 1 of Lesson 6-4, we learned how to graph equations in standard form. Now we're going to learn how to write them into standard form. What that means is take an equation that might be in slope-intercept form or some other form, point-slope form, which we're going to learn about in 6.5, or a form that's not really defined, and put it into standard form. Keywords for this lesson: standard form of a linear equation. We're also going to talk about x-coordinates, or x terms, y terms, and constant terms. So those are some other terms we're going to be using today. Let's review the definition of the standard form of a linear equation. The standard form of a linear equation is ax plus by is equal to c, where a, b, and c are integers. A has to be greater than 0, and a and b are not both 0, meaning this coefficient a right here, it has to be a positive integer or a natural number. B can be negative, and that's usually indicated by using a subtraction sign here, and our constant term has to be an integer. So we're going to see how that comes into play in a little bit. Example 4t, transforming to standard form. Write the following equations in standard form. I have the standard form here, ax plus by is equal to c, and if we take a look at the standard form compared to what we're given, and you should recognize this as slope-intercept form, we need to transform this into standard form. I've lined up the equal signs. And let's see what's going on here. The x term in the given equation is on the right. The x term in standard form is on the left. The y term in this equation is on the left in the given equation, and in standard form it's also on the left. C in standard form is a constant number, and that constant number is on the right in the given equation, and the constant number in the standard form is also on the right. So we're going to need to move 2/3 x to the left and mess with it a little bit to make it standard form. But the first thing we're going to do is get the x and the y terms on the same side. We're going to do that by subtracting 2/3 x from both sides. The x terms cancel, leaving us then with negative 2/3 x plus y is equal to 6. What we have to do now is clear this equation of this fraction, and we need to make this positive. To do that, or to get rid of this, or to clear this denominator 3, we have to multiply the whole equation, or both sides of the equation, by 3. When I multiply on the left, I have to remember to distribute to both terms. And when I do that, 3 times a negative 2/3 gives negative 2x. 3 times plus y gives plus 3y. And on the right-hand side, 6 times 3 is equal to 18. For this to be in standard form, the x term cannot be negative, so we need to multiply or divide both sides by negative 1. When I divide both sides by negative 1, what happens is it changes the sign of both of the terms in the numerator, so the negative 2x becomes 2x, the plus 3y becomes negative 3y, and the positive 18 on the right becomes negative 18. If we look at this standard form now, we have ax plus by is equal to c. A is a positive integer, and it fits this form. So we've converted our first full given equation into standard form. So let's put a little box around that to indicate that that's our final answer. In the equation on the right, we're going to take a slightly different approach. We waited to eliminate the fraction to the second step. In this case, we're going to do it in the first step. And in this case, you can see we have two denominators, 3 and 4. If we go 3 times 4, that'll give us 12. And that's the least common multiple of 3 and 4. So when we multiply the entire equation by 12, we multiply 12 times y to get 12y. We multiply 12 times 1/3 x. And 12 times 1 is 12 divided by 3 gives us 4. So that gives us 4x. And when I multiply 12 by 3/4, 12 times 3 is 36, and 36 divided by 4 is 9. If we compare to what we have now to this, we're still not in standard form. The y term is on the left, but we need to get the x term on the left, and we'll do that by subtracting 4x from both sides. Four x's on the right becomes 0, leaving us with 9 on the right. On the left, we'll write this as negative 4x plus 12y. Now, they can't be added together because they are not like terms. As we saw in the last example, the coefficient of the x term is negative, so we need to make it positive. And we'll do that by dividing both sides by negative 1. When we divide the left by negative 1, it changes the signs of both of these terms. So the negative 4x becomes a positive 4x. The plus 12y becomes negative 12y or minus 12y. And the positive 9 on the right becomes a negative 9. And there we have our equation in standard form. Example 5t, real-world problem solving. Write an equation in standard form to find the minutes someone who weighs 150 pounds would need to bicycle and swim laps in order to burn 300 calories. Use the data below. Well, the data is actually over here to the right. Then we have to define or figure out what our variables are in this problem. And when we talk about variables, and we usually talk about independent and dependent variables, but we really don't have that in this case. They both will add up to the whole. And in this case, we have a part plus part equals whole problem. And in this case, the whole is the 300 calories that need to be burned. The whole in this case is the 300 calories that need to be burned. The two parts are the parts of the calories that are burned up by doing the two different exercises. The two different exercises in this problem are bicycling and swimming laps. They're going to burn calories by bicycling and swimming laps, and they want to burn 300 calories. So what we'll do now is define our variables. We have two variables, and if we're thinking about standard form, let's use x and y. We'll say x is equal to calories burned bicycling and we'll say y is equal to calories burned swimming laps. We'll just put swim there. I ran out of room. So our two variables are x being the calories burned biking and y being the calories burned swimming. We have to go to the table then and see the rate or the coefficient that's going to be on the x and the y when we go to put our equation together. So from biking, the person burns 10 calories per minute, and while swimming, the person burns 12 calories per minute. We want to take these two and use those as the coefficients. The coefficient on the x being 10, so that would give us 10x. The coefficient on the y being 12. And these are our two parts. The first part being the calories burned while biking, and the second part being the calories burned while swimming. If we add those two together, that will be equal to the whole or the total calories we want to burn. So there's writing an equation in standard form, ax plus by is equal to c. This has been Mr. Pilarski on writing the equations in standard form. Thanks for watching. Bye-bye.